This is for Year 11 Methods. It comes out of Chapter 8. It's 8.8, question number 7. If f of x equals 2 log base 5 of x plus 5 minus 4, then what are the intercepts? The x-intercept is calculated when y equals 0. So moving the 4 over and dividing by 2, I get 2 equals log base 5 of 5. This point turning it into an exponential. Then the answer x plus 5 will equal the base 5 to the power of 2, which means x equals 25 minus 5, or x equals 20. To find the y-intercept, let x equal to 0. If x is 0, then this becomes 5. So I've got 2 log base 5 of 5, which is 2 times 1, minus 4, and negative 2. Part B says write down the domain. Part C says graph the function. I might graph the function. Because of the plus 2, I know it's been moved to the left 5. So I'll put in asymptote at x equals 5. I know I have a y-intercept of negative 2 and x-intercept of 20. Therefore my curve is going to look like that. So that's 20 and that's negative 2. So going back to part B, my domain will be curve bracket negative 5 through to infinity. And part C is drawn. Okay, in part D we need to sketch the graph of g of x on the same graph of f of x. So I've got f of x there redrawn. The x-intercept of g of x, make y equal to 0, so move the 4 over and divide by 2, that gives me 2. X plus 5 equals 10 squared in exponential form, therefore x equals 95. It's going to be all the way over here at 95. The y-intercept, make x equal to 0, so I've got 2 log base 10 of 5 minus 4. If I move that 2 up to make it a power on the 5, I've got log base 10 of 25. Now I know 10 to the power of 1 equals 10, and 10 to the power of 2 equals 100. So 10 to what power would equal 25 would be a number between 1 and 2. So that positive number between 1 and 2 minus 4 is going to be less than negative 2. It's going to be there somewhere at negative 4 plus log base 10 of 25. So that's my y-intercept. So obviously my curve's going to look like this, and its x-intercept is going to be a lot further to the right. But what happens over here? Does it stay below? Does it intersect at some point? So I need to find the intersection point. Okay, on to the third page. To find the intersection, I set the two equations to each other. I plus 4 to both sides, the 4's disappear. I divide by 2 on both sides, so the 2's disappear. And that gives me log base 5 of x plus 5 equals log base 10 of x plus 5. So when do two logarithms that have different bases equal each other? Well, really, they can only equal each other when I've got when the answers are 0. So I know that log base 5 of 1 equals 0, and I know log base 10 of 1 equals 0. So that's when they will be equal. So when will this equal 0 and this equals 1 when x equals negative 4, and this equals 1 also when x equals negative 4. So when x equals negative 4, this is log base 5 of 1, which is 0. When this equals negative 4, this is log base 10 of 1, which equals 0. Therefore, the x-intercept is at negative 4. So I know that these will intersect and cut across when x equals -4. And what will that equal? That will be 0, so it's going to be -4, -4. How can I compare the two graphs? Well, I can compare the two graphs by saying that they're both positive logarithmic graphs, that they have an intersection point at -4, -4, that when x is bigger than -4, f of x is larger than g of x. F of x for those periods will have a greater gradient than g of x. But when x is between -5 and -4, then g of x is larger than f of x, and g of x has a smaller gradient than f of x. They have different y-intercepts, they have different x-intercepts.